Okay, today we're going to be talking about rate of change and slope for section 3.1. Let's start with rate of change. Rate of change is the change of the dependent variable, or easier, let's get rid of dependent variable and just say that the rate of change is the change on the y and divided by the change of the independent variable, which is really the change on the x. So the rate of change is change in the y over the change of the x. So I went ahead and drew this table right here in blue. I want to find the rate of change. So I have the change between the y and the change between the x. So I have two quantities here. So I'm going to find the change between the 4 and the 6. Well, the change is to add 2. So on the y, it's a plus 2. For the x, the change is going to be plus 1. So if I wanted to find the rate of change, so I would write rate of change. That would equal the change in the y, which is a 2, over the change of x, which is a 1. So that means it's going to be 2 over 1, which equals to 2. Okay, so that's the rate of change. Now let's talk about what is slope, and then come back to rate of change so you can see the difference as we go along. So for slope is data that is for a linear, and the rate of change is constant, and that's the key right here. For a slope, the rate of change must be constant. So let's look at this table here in red that I have. Notice that the rate of change between 4 and 6 is plus 2. The rate between 6 and 8 is plus 2. 8 and 10 is plus 2. The rate of change between 1 and 2, 2 and 3, and 3 and 4 is plus 1. Notice how this is a slope because the rate of change is constant. So this has a slope of the change on the y over the change of the x, which is going to be 2 over 1. So the slope is going to be 2. So here's my slope for the red table. Now it's a slope because all the values are constant. 2, 2, 2, 1, 1, 1. You understand? Now let's go back to the rate of change. So let's say I wanted to add a few more numbers in here. Let's say the next number on this sequence was a 9. And the next sequence for the x was a 3 on this table. Now I want to find the rate of change between the 6 and the 9. Well, between the 6 and the 9, that's a 3. And then, of course, 2 to 3 is a 1. So this new rate of change is going to be different. It's going to be now 3 over 1, or 3. So if you're doing rate of change, all you need is two quantities. They can be different. So it all depends on what specific part you're looking for on your change. A slope requires that everything be the same. So the numbers have to be constant, and that's considered slope. So that means this would be a linear example. And rate of change can be linear or nonlinear. Okay, so there's the difference. Now, another thing that you need to understand is when it comes to a slope is really rise over run. So since it's a constant and it's going to be linear, you're going to have the rise and the run associated to that slope. Now, moving on to other things that you need to know. When it comes to slope of lines, a line that is moving up from left to right, if it's moving upward, that is considered a positive slope. So it's got to be moving upward. If you have something that is moving downward from left to right, that is considered a negative slope. So we'll show how you can tell which way it's going, and so that way you don't have to necessarily memorize which way it's supposed to point. Okay? So let's go into more detail about the rate of change and slope. So looking at the first problem, we're going to find the rate of change and slope using a table. The table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? What does the rate of change represent? So we look at our table and they're looking at distance over time. So we're looking at the change in distance divided by the change in time, or the change in y over the change of x. So let's first start by looking at that change. So looking at our table, we want to know what are the differences between 260 and 520, 520 and 460, and so forth. So let's just take the first one. The difference between 260 and 520 is 260 positive. The change between the time from 1 to 2 minutes is just 1. So our rate of change is the change in the distance over the change of the time. So that's going to equal to positive 260 over 1, which is really 260. Now let's be more specific what this means. So our rate of change is 260, but what does that mean? 260, and it's going to represent our y, which is feet. So there should be feet here on our dividing, over time, which represents minute. So it's going to represent 250 feet per minute. Okay, so there's our rate of change. But let's continue a little bit further. I go between 520 and 780, and the change is 260. So our rate of change is still 260. Between 2 and 3, it becomes another plus 1. From 780 to 240, it's 260. And between 3 and 4, it is 1. So again, if you notice now our change, it is plus 260, plus 260, plus 260, plus 1, plus 1, plus 1. Okay? So the first question says, is the rate of change in distance with respect to time constant? It is. Notice how the change for these values are constant on both sides of the x, change on the x and the change on the y. So that means that because it is a constant, we can also indicate that this is also a slope because it's a constant change. So the slope is 260. So what else does it tell us? Okay, well, it also tells us that this is going to be a linear function. All right, let's go on to the second part of the question. What does the rate of change represent? The rate of change represents the change between 260 feet for every 1 minute. So that's what you need to show, that it's representing feet over every single minute. And so we want to understand that this is a linear relationship between the distance and time for the march. Let's go ahead now and move on to problem 2. For problem 2, we're going to be finding slope using a graph. So we have two graphs here and we want to find the slopes. Before I get into how to find the slopes, let's go back to our beginning parts of the notes. Remember that a line with a positive slope slants upward from left to right. So it's slanting upward, that would be positive. A negative slope will slant downward from left to right. The key here is that we're always going to be reading from left to right. So we're going to do that for this example. So here, what we're going to do is we're going to always find our slope going from left, always go from left to right. So our first point as we're going from left to right is going to be this -2, -1. And we want to go to this point at 1, 1. Okay, so what you can do is to get to that point, you're going to need to go up 2 and 3 to the right. So our slope is rise over run. Our rise is going to be this, going up 2, and it's a positive 2. And our run is always going to go positive because you're always going from left to right. So this number, the run, will always be positive. So the denominator will always be positive of a +3. Since they're both positive, we're just going to leave it as 2/3. So that's our slope. Now let's look at the second one. The second slope, we want to start at -3 and 2. So we're going to have to go always from left to right. So that doesn't change. But we're going to be so we've moved left to right, so we're going to have to go this way. And then from there, we're going to have to go down to get to the point, the second point down here. So from left to right, I told you that this will always be positive. So from left to right, you have 5 values here of +5. But then you have to go down. When you're going down, that means that and this is a run, our rise is going to be going down. So therefore, our rise is going to be going down. So that's a -4. So this would be -4. So now if we do our slope, our slope is rise over run. Our rise is going to be -4. Our run is going to be +5. Get rid of and keep one sign. Since one's negative, we're going to put a negative in the center, and it's going to be 4/5, or -4/5. So this is going to be our slope. The key is, guys, always go from left to right. The run will always be positive. And always go from left to right to choose your first point. Okay, this is going to conclude the first part of the video. I'm going to make 3.1 into 2 parts. So this is part A. First, I need you to understand slope and rate of change before we move on to part B. Once you've completed the problems, you can go ahead and watch the second part of the video for 3.1